Hello friends, welcome to our channel. In this lecture, I would like to explain another important example which is based on the short column. See here, this is the example 3. Design a short column square in section to carry an axial load of 1200 kilonewton using M20 grade concrete and Fe415 steel. So first write down the given data. What are the data which is given in the question? So that is design a short column square in section means the square in sections means it will be some a by b like that, a by a, which is a square in section. Okay, whatever the dimensions you will get, it will be same. For example, if they are asked rectangular means you can design some a by b like 200 by 300, 300 by 400 like that. Whenever they are asking square in cross section means, so you will get both dimensions will be same like some a by b, a by a. And axial load, they are given that load will be equal to 1200 kilonewton. And again, M20 grade concrete means FCK will be equal to 20 Newton per mm square, which is characteristic compressive strength of the concrete. And Fe415 steel means Fy 415 Newton per mm square. So all these are the given data. For this data, you have to find the square column and then followed by the design. So already yesterday I told you one formula based on this axial loaded short columns. So see your code book, so which was in page number 71 in IS 456, there will be one formula short axially loaded members in compression, that is PU equal to 0.4 FCK AC plus 0.67 Fy ASC. So based on this formula, you can design the problem. See here, the formula will be PU is equal to 0.4 FCK AC plus 0.67 Fy ASC. So this is the formula. Each and everything terminology there here. PU equal to axial load on the member. FCK is the characteristic compressive strength of concrete. AC is area of concrete. Fy is characteristic strength of the compression. ASC is the area of the longitudinal reinforcement for columns. So see here, what about your FCK? FCK is 20 Newton per mm square. Fy is 415, and here already load is given, that is PU equal to 1200 kilonewton. So then find out the PU, which is factored load. So here this is the PU, that is a factored load, that is for 1.5 times of the load which is given, that is 1200 kilonewton. That one will be equal to 1800 kilonewton. For example, if you have to change in terms of newtons means 1800 into 10 to the power of 3 newtons. So your factor load will be equal to 1800 into 10 to the power of 3 newtons. Then here there will be area of concrete. AC is the area of the concrete and AC is the area of the steel. So already, if you assume here, this is the cross section of the column, which is square. So this is the gross area. So assume that gross area will be equal to AG. So overall gross area will be equal to, in this there will be area of the concrete and at the same time area of the longitudinal bars, that is area of the steel. Area of the steel means the area for the longitudinal bars in the columns, means overall gross area will be equal to area of the concrete and again the area of the steel. Okay, so this is the gross area. Here assume area of the steel will be equal to 1% of overall gross cross sectional area. So here you please assume area of the steel will be equal to 1% of gross cross sectional area. 1 by 100 means 0.01 Ag, means area of the steel will be equal to 0.01% 1 gross cross sectional area. Then what about the concrete here? See here, area of the concrete will be equal to Ag minus ASC, means here I am sending this ASC this side. Then if you simplify that one, you will get Ag minus 0.01. So again this AC will be equal to 0.01 times of Ag. So I am substituting in place of AC that one. So then that one will be equal to 0.99 Ag. So area of the steel will be equal to 1% of the gross cross sectional area. First assume that one. Based on that one, you will get area of the concrete, that is 0.09% of Ag. So that is 0.99 Ag. Then substitute all the values here, that is Pu is equal to 1800 into 10 to the power of 3 in terms of Newton, and 0.4, FCK is 20 Newton per mm square, where area of the concrete equal to this value, that is 0.99 Ag plus 0.67 into Fi is 415 into ASC is, what is the value of ASC here? What we assumed, 0.01 Ag, that is 0.01 Ag. Then simplify this one. Here the value Ag will be there, which is unknown here. If you simplify this one by using your calculators, you will get Ag value will be equal to, that is 16822.4.3 mm square, which is in some approximation. So if you simplify this one, so approximately you will get around this value. So whatever the value will get, take down that value as it is. And already I told you, so Ag is the gross cross sectional area. So already we assumed that one, some A by A, which is A square. So therefore A square will be equal to 16822.4.3. Then square that one. So if you find out the column, so like square root of A square will be equal to, and again A equal to some particular square root of this value. If you simplify again this value, you will get A value will be equal to some 4.2, 410.2 in mm. So almost all the value will be higher than 410.2. So then round up that value which is near to this value. So like approximately 420 and by 420 in mm, which is a squaring section. So we are finding one side of the value. So the remaining side will be, which is square, the value will be same here, that is 420, 420. For example, if this value is some 409 means we can round off that one will be around some 410. So here the value will be higher than 410. That is the reason we are round up into the next digit, that is 420. So if you want 415 means like that also you can design, but always see the particular base value, then only it will be very convenient for doing the calculation, and in the practical also it will be very convenient to provide like this. So the size of the square column will be 420 by 420 mm. So what I am doing here, first we are assuming area of the steel will be equal to 1% of the gross cross sectional area. In that we are finding area of the steel will be equal to 1% of the gross cross sectional area. Based on that we are finding the area of the concrete, and again we are substituting the two values in the given codal formula, which was in page number 17 IS 456 2000. Okay, then simplify the values. So you will get the area of the gross area. So based on that gross area, so already we know gross area will be equal to A by A, that is overall area of the square column. So therefore A square will be equal to this value, and again simplify, you will get A value here, that is 410.2. So which was the square column, so we can assume that both sides will be equal here because of the square column, that is 420 by 420 mm. So for that you have to provide the area again. So therefore area of the steel, so area of the steel will be equal to 0.01 gross cross sectional area. So gross cross sectional area, how much here you will get cross cross sectional area will be 168 224.3. This is your area of the steel which is obtained based on that formula. So how much it will be? It will be around 1682.2 mm square. Then so this is the area of the steel. For this one we have to provide the number of bars, dia bars. See here, so based on this area, so that is 1682.2 mm square. So we are going for the trial section. So here minimum number of bars required for the square column. So how many bars? The minimum number of bars will be 4 for this rectangular or square cross section. If it will be circle means minimum number of bars will be 6. So therefore I am starting my trial with 4 number of bars. And what about the dia? So the dia will be, I am coming from some 20 dia. Okay, 20 dia. So simplify this one, 4 into pi d square by 4. So 4 and 4 will be cancelled. So you will get 3.14 into 20 square. So what is the value of that one? 3.14 into 20 square. That is 1256 mm square. 1256 mm square. It is not suits here. Why? Because whatever the area we are providing based on the 4 bars means it is lesser than the required value. So this is the required value. And go for the next trial, that is 4 bars of 25 dia. If you simplify in the same way, 4 into pi d square by 4. If you simplify again this one, you will get 1962.2 mm square. Okay, so this value is higher than the area of the steel required. So therefore this value suits here. So therefore if you want means you can provide 4 bars of 25 dia. Otherwise you can check the trial versions by using 6 bars also. You can check the trial versions by using 6 bars, like 6 bars of some 20 dia. Like that also you can check 6 bars of some 25 dia. Like that also you can check based on the trial versions. But here almost the value suited here, that is 4 bars of 25 dia. Therefore we are providing here, provide 4 bars of 25 dia. Therefore that ASC provided will be equal to 1962.2 mm square. Then check the minimum area of the steel and maximum area of the steel according to the given condition for the based on the Indian Standard Code Book. So check in your code book, which was in page number 48. See here 26.5.3. So here they will be mentioned on class. The cross-sectional area of the longitudinal reinforcement shall not be less than 0.8% nor more than 6% of the gross cross-sectional area. Means the minimum steel whatever we are providing in the longitudinal for the longitudinal reinforcement, it shall not be less than 0.8% of the gross cross-sectional area and not more than 6% of the gross cross-sectional area. So that code, so that is 0.8% of gross cross-sectional area, that is 0.8 divided by 100 into P into D. So here B and D will be equal. So that is 200 420 by 420 into 0.8 divided by 100. How much you will get that one? So based on your simplification, you will get that one will be equal to 0.8 divided by 100 into 420 by 420. So it will be equal to almost the value will which is near, that is 1411.2 mm square, and it does not more than, so which is area of the steel maximum 6% of gross cross sectional area, that is 6 by 100 into 420 into 420. If you simplify this one, again you will get a 10 comma 584 mm square, around 10,600 mm square. Means the minimum area of the shield required for this type of columns will be equal to 1411.2 and maximum it does not exceeds 10.584. But we are providing the value which is greater than minimum. Therefore, area of the steel we are providing is greater than area of the steel minimum. So therefore, it is in safe limits only, that is 1962.2 mm square and that is 1411.2 mm square. So in some cases, based on the gross cross sectional area, you will get area of the steel will be lesser, like 1256. At that time we have to provide area of the steel will be minimum 1411.2 on that particular column. Means even though it will be lesser, area of the steel whatever we are providing will be lesser than the minimum, means we can limit that value to the area of the steel minimum and provide minimum steel on that particular column. Okay, but here it will be in the safe limits only. Then our next step is lateral ties, providing lateral ties. So for lateral ties also there will be one condition in the code book which was in page number 49. See here in the next paper itself, which was in page number 49, that is pitch and diameter of lateral ties. So pitch and diameter of the lateral ties. So page number IS 456 2000, page number. It is always to remember page numbers for easy reference. Then our first point is, see here, observe in the code book, the pitch of the transfer reinforcement shall be not more than the least of the following, and the diameter of the lateral ties. It talks about the diameter of the lateral ties and it talks about the pitch. So what is the meaning of the pitch here? Means, for example, in the beams we used to provide spacing. In the beams we used to provide stirrups. So stirrups in the beams, columns we used to call as lateral ties. Okay, lateral ties. But here stirrup to stirrup we used to call as spacing, but tie to tie we used to call as pitch in the columns. So that is the difference between beam and column. So stirrups are used in the beam and we are providing spacing for stirrup to stirrup. Lateral ties are used in the column and we used to provide with some distance which is called pitch here. So we are producing same mild steel and same HYSD 8 bar only, but the terminology will be different here. In the beams you use it to called as stirrup, here it is used to called as lateral ties. So the conditions will be different in the column and the conditions will be different in the beam. Just I am telling in the logical way here. Then so the diameter of the lateral ties according to the code, it will be shall not be less than 1/4 of the diameter, 1/4 of the diameter of the largest longitudinal bar, and in no case less than 6 mm. So it is not 16 mm. Please correct this value which is 6 mm. Why? Because minimum bar will be using for lateral ties and stirrups will be 6 only, not 16. Please make it correct that one. So first one will be diameter by the 4 shall not be less than the diameter of the longest longitudinal bar by 4. So what is the longest longitudinal bar we are using here? 4 bars of 24 dia. Okay, 25 dia. So 25 divided by 4, that is 25 divided by 4. So which is 6.25 mm, which is 6.25 mm. So according to the first condition, what I am taking here, shall not be less than 1/4 of the diameter of the largest longitudinal bar. So largest longitudinal bar what we have provided in our design, 4 bars of 25 dia. Therefore I am taking 25 here. And the second condition, in any case it does not greater than 6 mm. Okay, so these two conditions, shall not be less than 1/4 of the diameter of the longest longitudinal bar and in no case less than 6 mm. Okay, so for example here you will get 6.25 mm. Therefore what we are doing means, I am round off this value to the next dia bar which is 8 mm only. There will be no 7 mm dia bar available in the market. Therefore I am providing next dia bar which is approximately equal to 8 mm. But after solving this one you will get maybe some 5 mm. At that time what we have to do means, we have round off this value and provide least requirement in the code. So code recommends least requirement will be 6 mm. So whenever you will get this value below 6 mm means, you please provide minimum 6 mm on that particular column. If it will be greater than 6 mm means, go to the next number which is 8 mm bar available in the market. You please provide that lateral tie in the column. And next point is pitch. Already I told you pitch is meant for the spacing. Hence here we are adopting, hence adopt 8 mm dia bars, 8 mm dia bars. And next point is about the pitch. So for pitch, what are the conditions mentioned? See here, the pitch of the transfer reinforcement shall be not more than the least of the following. Means the distance shall be not more than these condition. The least lateral dimensions of the compression member. So see here, the first condition is least lateral dimension, least lateral dimensions of the compression member. So what is the least lateral dimensions? Here we are using the column that is 420 by 420 mm. So if it will be a rectangular means, what we used to do, some 200 by 400 mm means, we are taking 200 here. But here for square column, both dimensions will be same. So there is no least and no highest value here. Therefore there will be only one value which is 420. So we are taking lateral dimension is 420. In cases of circular, whether that condition exists means, you can take down the diameter 300 means, directly take down the dia only. So that is the first condition. And Second condition will be, what is the second condition? See here, 16 times the smallest diameter of the longitudinal reinforcement bar of the tie, means 16 times of the diameter of the longitudinal bar. But here we are providing in our condition 4 bars of 25 dia. Maybe sometimes, for example, in some rectangular columns, somebody will provide 4 bars of 20 for a particular column, any column of size some 300 by 400 meter, means 2 bars of 4 bars of some 25 dia and 2 bars of 20 dia. At that time, what is the condition here? 16 times of the long diameter of the longitudinal bar, that is the condition, smallest diameter of the longitudinal bar. So in this condition happens means you can choose 20 bar at this condition, but here we are providing only 4 bars of 25 dia of the long. We are providing only one dia bar, which is 25 dia bar in our design. At that time you can take down 16 into 25 directly. But somebody use for rectangular columns 4 bars of 25 dia and 2 bars of 20. At that time you can take least of the 2 dia bars. So simplify this one, you will get 25 times 16 means almost you will get 400 mm. 400 mm. And what about the third condition? What about the third condition? See the third condition here. The third condition is 300 mm. 300 mm. 300 mm. So out of these three, provide lesser value. Lesser value means we have to check these three conditions, in that provide the lesser values. So your least lateral dimensions will be 420 mm, 16 times of dia will be 400 mm, and minimum conditions will be 300 mm. So after solving these three conditions, maybe you will get some 200 mm here, means you can provide 200 mm only. So out of these three, whichever is less. So here these two values are higher than these 300 mm, but we are limiting that value to 300 mm. So in any case, the pitch will not be higher than these three values. So out of these three, your lesser value is 300 mm. So based on that, we can provide the lateral tie of 600 mm, means provide lateral tie of tie at 300 mm center to center. Okay, then these are the conditions for our column. Then draw the detailing of square section. So here this is our square section. And again with some minimum cover, we are providing the bars also. So minimum covers will be 40 mm for the columns. So I am providing the dia bars here. So I am using blue sketch for dia bars. So first you have to provide the longitudinal dia bars, then you have to provide the tie. But here I am drawing reverse. So first you have to two-legged it and provide legged will be like this, which was in two-legged stirrups. Then this is the dimensions of the column, which is 420 by 420, and we are providing some minimum cover which is 40 and 40 here, and two these two are the, so here I am mentioning that one, so that is 4 bars of 25 dia. Okay, so this is the cross section of the square column. This is the cross section of the square column. For this one you have to provide the elevation also. So this is the outer one, like this as it is. So these are the dia bars. So actually dia bars we have to provide with the blue sketch. So with dia will be around 25 mm. So if you cut this section, and if you see these bars means, for example, cut the section like this and see anywhere, or else you can see from front view also, you will it will be visible like this only. There will be only 2 bars visible. And I am providing outer bar. So the bar is continuous, therefore I am showing like this. Here also it will be continuous. I will provide the continuous symbol. Okay, so this is continuous here. Show the continuous symbol, and these two are the bars, and this is the lateral tie. Lateral tie. So what is the lateral tie we are provided here? So the lateral tie we are provided 8 mm, 8 mm lateral tie. So write down that one. So what, in what way it will be appears means lateral ties. It will be like this. So this is the lateral tie. So all these are the lateral ties. So with same distance, with some pitch value. So here the pitch value will be between the lateral ties, that is 300 mm, and these are the lateral ties of 8 mm dia, and these two are the longitudinal bars, which is these 4 are the longitudinal bars. It is, please remember, these 4 are the longitudinal bars of 25 dia. So this is the cross section of the circular square column, and the elevation of that particular square section. So this is the way we have to design and provide the detailing of that particular example. I hope you understand this lecture. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends, and subscribe our channel. Thank you so much.